welcome to today's webinar with SkillUpRight. Today we are going to talk about how do we deploy applications on Kubernetes, right? So we will talk about the replica sets, deployments, and services. Okay. If you were part of yesterday's discussion, you would have already seen me creating some deployments and accessing the applications. But I did not explain what I was doing because the topic was how to set up an EKS cluster and not about how to use it. So today we will see how do we use a Kubernetes cluster by deploying applications over there. All right. So let me start with sharing my screen. All right. And let's start with the MS Paint, right? So if you have to deploy an application, or if you want to deploy an application in Kubernetes, what do we do? So we all know that applications can be created in something called as pods, right? So maybe if this is a pod, for example, excuse my handwriting, if this is a pod, then in the pod, well, pod is an abstraction in Kubernetes, right? So pod ensures that all the containers inside the pod are running, and maybe multiple containers in the pods are running, and then each pod gets an IP address, and you can mount volumes in the containers and things like that, right? You deploy your application like this, generally. And any application running inside a container may be on some port, for example, here on port 80, if an application is running on this container, it can be accessed from within the cluster. So that means any of the cluster machines, you can access this application by browsing on the pod's IP address. For example, it could be 10.25.68.71:80, right? So you can access the application like this. And this will ensure that you access your application within the cluster bud, right? So if you have many nodes, let's say these are all nodes, and in the nodes you have your pod running, and in the pod you get your IP address of the pod, an application is available on port 80, then this application can be accessed from anywhere in the node. So any user logged in here or any user logged on this machine can access this application, right? And that's because the pods and their IP addresses are only available within the cluster. They are not reachable from outside the cluster. So let's say these are your cluster machines, and then this is your laptop, right? And from a laptop, if you say, I want to access the application on running on the pod, and here is the application's URL, well, you won't be able to access it. Yeah. Vinod, can you please mute? Vinod, can you please mute? Just 1 second. Okay. Anyways, right. So you access your applications via this URL, but again, that's applicable only within the cluster, right? Now let's talk about one more limitations by deploying your application like this. Let's say you want to deploy your application, and you deploy it with a pod, and for some reason the pod crashes. So maybe there is no resource on the node to run the pod anymore, or somebody logged into the cluster and deleted this pod, and the pod crashes. If that happens, then the application is gone. Any of the users will not be able to access the application, even within the cluster, right? So now the question is, how should we deploy an application? Because deploying via pods is not working out. Yeah. So to solve this problem, we have a concept of something called as replica sets. Okay, let's choose pen. Replica sets. Okay. What replica sets do is you can say, hey, um, hello Kubernetes, I want to deploy my application, right? The application is based on this particular image, and I want the application, or I want, let's say, 3 copies of my applications to be running, right? So you say, I want to create a set of replicas of my application. So Kubernetes, please ensure that there are 3 pods running, and all the pods have the containers based on this image, right? Now, when you tell this to Kubernetes, Kubernetes will ensure that at any point of time in a cluster, there will be 3 pods running across the cluster somewhere, 3 pods running with this configuration. Now, Kubernetes will ensure that 3 pods will be running always. And if one of the pods dies, then Kubernetes is going to create a new pod. But it will ensure that there are always 1, 2, and 3 pods running in the cluster, right? So that your application never dies. There is always one or the other instance running to let you access the application. Okay, so now the problem is solved that, okay, pods will be there. There will not be any movement in the cluster when we will not see the pods. Pods will be there. But now the problem comes in another way. Whenever the pods are created, they get their own IP addresses, right? Each pod gets their own IP address. And the users can choose which pod to access the application from. But again, let's say the users are accessing the application on pod number 2 here. But this pod dies. For some reason, this pod dies. And if this pod dies, Kubernetes, as promised, will create replacement pod. But it will have a new IP address. Now, these users were accessing the application with the IP address of the old pod, but now the pod has died, a new pod has come up, and it has new IP address. So how will the users then access the application? They should always be updated with the latest IP address of the pods on which it is running, right? And that would be a problem. So what's the solution? The solution is a new paint window here. The solution is to expose your applications as services, right? So when you create a replica set, right? In the replica set, you will say, I want 3 pods running. So 1, 2, 3 pods. Doesn't matter on which node and how many pods on one node. That does not matter right now. Kubernetes will ensure that the 3 pods are running because you mentioned that I want 3 pods in my replica set. And each pod will get an IP address. and the application will be running on port 80 on each pod, right? Port 80 is an example, it could be any port. Now, these pods are replaceable. Some pods may die, some new pods may come up, and the IP address will continue to be changed with the life cycle of the pods. So what we do is, instead of asking the users to talk to the pods directly, we create a front end or something of the sort of a load balancer in front of the pods. So in Kubernetes, you can create a load balancer and they are called as services. So you create a service. And when you create a service, you get a static IP address. Static IP address for a service. This IP address is never going to change for this service, right? But what's the use? So let's say any user who is within the cluster will access this static IP address, and the load balancer or this service
To change
will
for the
redirect
service,
this request
right?
to any
But what's
of
the
the
use?
pods
So let's say any
which
user
is part of the replica
who is
service,
within the cluster will access this static IP.
right? So we create a service. The service will give a static IP address, and then any request coming to that static IP address may get redirected to any of these pods. So now, if this pod dies, let's say this pod dies, a new pod will be created. A new replacement pod will be created, which will have a new IP address. But the service will automatically come to know about the new pod that is created, and it will include that in the request redirection. Okay. So services ensure that you have a single entry point that you can give to your end users, and they can access application without worrying about pods and their changing IP addresses. So let's see an example of this. So I have initiated a cluster creation. I'm not sure if it is created. So this cluster is created. It does not have any nodes. Strange. Just 1 second. I'm not sure why. Maybe it is creating the nodes. Just a second. Yeah, the cluster is not created properly. I'm going to delete this one and create a new one. Just a second. I'm not sure why we're not getting response from Kubernetes. Just 1 second. I'm checking if my credentials are set up correctly. Let's set them up. All right. So I have started a cluster deployment. It may take 10 minutes. Yeah, it may take 10 minutes. So now let's move on to a different topic on replica set itself and see how does all this happen. Okay. So we understand what is service and how replica set is a copy or set of pods belonging to the same application, right? So when you create a replica set, you have to define the scale of the application that you are running, right? Here we have defined that we want 3 copies of our replica set. Okay. Now, why do we need 3 copies? A single copy of your pod should be okay. The application will be running. But then, if that pod dies, then you need some time, or some time will be taken before the new pod comes up. If your application takes too much time to come up between the pods, then there could be some downtime that could be observed by by the users. So what you do is you create multiple instances of applications so that even if one pod dies for some reason, there are other 2 pods which can continue to serve the requests, right? So you want high availability of the application or resiliency of the application, right? So that's why you want to set up the application at scale. There is another reason to set up the application at scale. If your application is very highly accessed, that means there are many users who are accessing your application. Just 1 or 2 or 3 copies of your application may not be able to take the load coming in from the users. So if there are maybe 1 million users accessing your application, then a single pod will crash. There is no question about it. Even 10 pods will crash. So you may want to have a capability to scale up your application as and when the load increases on the application, right? So you may say, instead of 3 copies of my application. Since I see that there is high load on my pods coming from external users, I want to run 300 copies of my applications. So then Kubernetes will take this request, and instead of running 3 pods, it's going to run 300 pods, right? So using replica sets, you can also define at what scale does your application run. All right. So that's there now. So that's the reason why we have more copies. You can also say, I just want 1 copy. If you just want 1 pod to be running there. Huh? So yeah. Now there could be a situation, or there will be a situation when you have deployed this application, right? You have deployed this application, but and this application, all these pods have some image, right? Let's say all these pods are running based on Nginx version 1.20. So all these pods have Nginx version 1.20. 1.20. Now, later you may want to upgrade your application. Maybe 6 months down the line, Nginx releases one new version called 1.21. And you want to update your applications to use Nginx 1.21. Right? How will you do it? How will you update your replica set to use application 1.21? You cannot simply change the configuration and say now use 1.21. Right? That can work, but you lose the history. So older deployments will be, or older pods will be gone forever. So to manage your applications, versions of applications, and roll out new versions of your applications, you do not directly deploy replica sets. What you do is you use something called as deployments. Okay. So what happens when you create a deployment? Now, when you create a deployment, you specify that you say that, hey, I want to create a deployment called my dep or dep or my dep, and in this deployment, I want Nginx application 1.20 and 3 copies. Right? Now, my deployment, what it is going to do is it's going to create a replica set. And in the replica set, it's going to create 3 pods with this application version. So 3 pods with this application version. So 1.20, 1.20, 1.20. And later, once this replica set is running and applications is running and all that is working, you may come back and say, hey, deployment, now I want to release a new version of an application, update my pods. Instead of using Nginx 1.20, it should use Nginx 1.21. So what will my deployment do? The deployment is going to create a new replica set. Right? Then it's going to scale down this replica set, the older one. Let's call it as replica set 1. It's going to scale down the replica set 1 by killing off all the pods. So it will slowly, one by one, kill all the pods so that there are 0 pods running for this replica set. And it's going to create new pods for this replica set. And all these pods will have 1.21. Okay. So a deployment manages replica sets. A replica set manages deployment pods, and a deployment manages replica sets. And when you update this image, right, from 1.20 to 1.21, Kubernetes keeps a history. So it says that version 1 of my dep had image version 1.20. It was using image 1.20. Then somebody said release version 2 and it is 1.21. Then if you again 6 months later say, hey, now to use 1.22, then this all will be scaled down. A new replica set will be created, replica set 3, and new pods will be created. And Kubernetes will remember that 1.23 version is now released, version number 3. So the replica sets continue to exist, but no pods will be managed in the replica set, right? And it will remember the history of the replica sets. 1.20 version 1, 1.21 is version 2, 1.23 is version 3. Now later when you say, hey, I think there's a problem in the latest release. Can we revert to the old release? So we can tell deployment, hey, undo my previous rollout. So I rolled out a new version, undo my rollout. And when you say undo my rollout, Kubernetes will fall back to the previous version of the application. That means it's going to scale this replica set down to 0, and then it will scale up this replica set back to 3 pods, right? So it can scale up or scale down any previous replica set based on which one you want to run. Okay, so this is what happens when you deploy applications using replica set and using um, deployments. Any questions? I'm not seeing any questions from anyone. So maybe the tool is not showing me, or maybe people are really not asking questions. I can take some questions for 5 minutes. And I think in next 5 minutes or before that, our cluster will be set up. And then we can have a demonstration. So I think this cluster is up, but nodes are not yet there. Hopefully nodes will also be created very soon. No questions? This is strange. I'm not seeing any chat messages, so We still have to wait a bit for node group to create. Maybe not much time. Give me maybe 2, 3 more minutes. Okay, I'm still waiting for the cluster to be up. Unfortunately, it is taking too much time. Okay, yeah, so I see that there are 2 nodes. It will come up. It has not come up yet. Nodes. Okay, the nodes are ready. Okay, good. So if the nodes are ready, oh, come on, there is some. Oh my God, I was on mute. I was answering the questions, but I was on mute. So the questions are looks like there is some problem in the chat window. I don't see any questions. But the SkillUpRight coordinator is forwarding me all the questions offline. So one question is, how do we enable or implement auto scaling either up or down? there is something called as Kubernetes Autoscaler. It's called Horizontal Pod Autoscaling, or HPA for short. And you can set it up. So for example, if you see here, if you have a deployment or a replica set with certain number of pods, and then you can create an HPA or a pod autoscaler and say, hey, monitor the CPU and memory utilization of these pods. And if it increases beyond certain points or decreases or increases beyond certain point in respect of how much CPU or memory is utilized, then add more pods, right? And if the load comes down, reduce the number of pods. So you can do that using HPA. Another question is, how many replica sets can run in parallel? You can run any number of replica sets in parallel, provided they are not part of same deployment. If you create a deployment, then deployment will ensure that only one replica set runs. Right? Previous or later version of replica sets will not run. Only one version of replica set will run. Third question is, how many rollbacks can we perform? So if you create a deployment, and in the deployment, if you create 10 releases or 100 releases, it doesn't matter. You can fall back to any of the previous releases. Okay, so now my Kubernetes clusters is ready. kubectl get pods. If I say, I should not see any pods running. Yeah. Now let's create a deployment. Create deployment. And I say that the deployment name should be mydep, for example. And I say that for the deployment, create the pods with image nginx. And the applications will be running on port 80. And I want 3 copies of my pods. So 3 copies of pods based on nginx image, and on port 80 on all of the pods, the application should be available. Press enter, and we should see a prompt that the deployment is created. Now let's come to our UI because it's easier to show you from here. And let's go to our workloads. So let's see what workloads have been deployed. And you see a mydep deployment is created. Yeah, this mydep deployment is created. Right, let's open this mydep deployment. And now you will see that this mydep deployment has created 3 pods. It has created these 3 pods. Right. Then let's go back here. Okay, it doesn't show us here all the details, but let's come back to our kubectl client here. Yeah, and I say kubectl get kubectl describe deployment, my deployment. Deployment, my deployment, my dep. If I describe this, you will see that some details about the deployment, name, on which namespace it is running, when was it created, what is the label, how many replicas are required, and then you will see replica sets. So it manages replica set, and this is the replica set that is running as of now. So it creates a replica set underneath, under the hood, it creates a replica set and deploys it. So it's a kubectl get replica set, which is get rs. Rs is short for replica set. If you run this command, you should see that there is a replica set created automatically by Kubernetes. Right? Now I can say, well, if I describe the Kubernetes, the mydep deployment, it says that it's running on based on image nginx. Now let's say, hey, let's set image of the deployment my dep, and let's say the nginx container should use nginx colon 1.19, right? This is what I'm telling. I'm telling Kubernetes set the image, Docker image for the deployment mydep to use nginx 1.19 in the container nginx in all the pods, right? And I'm going to record this statement. Press enter. What do you see? Image is updated. kubectl get pods. If I list down all the pods, you will see that let's watch the pods, how they are running. And you will see that it is now creating new pods. So new pod is created and it is terminating the older pods. So 65VZV was running and now it is terminated because it was part of this deployment. So older deployments are scaled down. All the pods in that deployment are terminated and new pods are created. Right? You see, all the pods are being terminated and the new ones are now created. So if I do a get pods now, you will see an entirely new set of pods. Okay, sometimes there seems to be a network issue. Okay, not sure why. Um, so you see here now, this is what events happened in the replica set. So the older replica set was scaled down, right? And finally to scale down to 0. And then the new replica set was scaled up to 3 pods. Okay, so this is what happens. And let's see, it could have been better if I showed you here. Yeah, so now you see these pods. And if you say kubectl get replica sets, you see now there are 2 replica sets, both managed by mydep, but new versions are up. Okay, now how do we access these applications? Well, all we need to do is expose the deployment. kubectl expose deployment mydep. And I want to expose it as type load balancer so that I can access it from outside of the cluster. And port should be 80. when I expose the deployment, it is going to create a service for me. And if I say kubectl get service, this is a service that is created, and I can access the application on this endpoint, right? I can access the application on this endpoint. It takes maybe a couple of minutes for this endpoint to start working. So let's give it some time. Maybe a little bit more. So yeah, I mean, it will come here. And if you see here, maybe before wrapping up, I can show you here. If you say kubectl describe service, if I describe this my dev service, you can see that the service can be reachable. Yeah. And here, these are the pods which will respond to any request coming to the service. And all these pods are part of our deployment replica sets. So if one pod dies, a new one will become, and the IP address of that pod will be used here. Okay, so it doesn't matter if a pod dies or if scale down or scale up happens, everything will fall into place. So now you see Nginx is here, and I can scale up kubectl scale deployment my depth. I say replicas is equal to 5. I want to set the scale of my deployment to 5 replicas. My depth. So you see, application is scale. If I do get pods, come on, again this problem. But yeah, we can see it in the GUI. So if I go here, and if I go back to the structured view of my deployment, and if I refresh this page, doesn't even show services, right? But I have to service. In the backend, this list will be updated to also add IP addresses of the 2 new pods, because now scale has changed to 5, right? So if I say describe service my dev, you can see here there are 5 pods, and come on. So there will be 2 new pods here. So to conclude here, this is how you can deploy scalable applications in Kubernetes. You should use deployment so that you can switch between different versions of applications, and you can expose your applications using services. Always do that so that you can access your applications without worrying about pods going down or application going down, right? They will be available all the time. Okay, so that's all I wanted to discuss with you. Now, unfortunately, I'm not able to see the questions. You see, my chat is not updating here. I'm not able to see the questions. There's some problem with this webinar tool. And, but yeah, hopefully we will meet again soon. And that time we will talk about some new topics. So thank you for joining us today. See you next time. Bye.